Straight line lesson 7, completing our notes, pulling things together. In the past, you've been asked to work out the distance between 2 points, or working out the length of a line. So something like this, all right? And if we were asked to work out the length of this sloping line here, so we're going to call it D for just the distance, all right? Because I'm not going to use an L because it looks like a 1. I'm not going to call it X because I've already got a coordinate grid sketched out here. This is the X axis. Again, we should always fill in X and capital Y there to say that. So I'm not going to use an X for the sloping one here. I use X's now for X coordinates. But we know from the past how to work out the length of a line here. We would say, well, I'll make it a right angle triangle. So I'll put in a horizontal line from the first point here and a vertical one up here. That makes a right angle triangle, and I know how to do that. So for example, if this was a point down here, something like -2, 3, all right, and this one up here was the point, let's say 10 along and 8 up. Then if I want to know the length of this line here, I would say, all right, d squared equals, I'm going to use Pythagoras' theorem. So from here to here, well, I know that this bit is 10 along because of these coordinates up here. That's 10 along, and this is -2. Oh, the whole length of this line must be 12. And likewise, I'm going from 3 up to 8 up. This must be 5. So as I say, in the past, perhaps you plotted points on a grid and counted the squares along and up, but we don't need to do that. And certainly you don't need to do that at higher. We can just say this length is 12 because it's 10 plus 2. This length is 8. Oh, take off the 3 down here. This is 5. So I can do my calculation. I'll say, all right, d squared is 12 squared plus my 5 squared. That would work out. You can put in an in-between line if you wish, but that's 169. That's what d squared is. Let's not forget to square root it. The amount of times I've seen people forget to do that and say, quite cheerfully, we'll say the length of that line is 169 units. That's clearly not the case from the diagram. Square root of 169, 13 units. Simple Pythagoras, really. Now, how did we work at this 5 here? You can say, yes, it's 8 up. Subtract the 3 up that we know from here. That's just a change in y. 8, take away 3. That is the change in y, gives me the 5 there. And it works going across the way too. I can say, yes, it's 10 plus the 2 here. Or I can just say, let's work out the change in x. That's 10 along, because it says this point's 10 along. This is 10 along. Take away -2. Oh, 10 take away -2 is 12. So in fact, we have a formula that we can use for that. So on page 14 in your notes, let's complete that. Working out the length of this line here, call this point 1. So it's coordinates x coordinate 1, y coordinate 1, x coordinate 2, y coordinate 2. It's a right angle triangle. What's the length of this side? This is the change in x values. This is my change in y coordinates or y values. So here's my formula. It's Pythagoras. One side is change in x. I know I'm writing x2 minus x1, but just like with the gradient formula, I'm reading it as change in x squared, because it's Pythagoras, change in y squared, and don't forget we square root the whole thing. And that's called the distance formula. So when you see that, please don't panic and think, oh, it's another formula to learn with x's and y's and x1s and y2s, and when do I add and when do I subtract? It's just Pythagoras, change in x squared, change in y squared. And we've been doing Pythagoras for a long time now. Complete your notes on page 14, please. And the main thrust of this, intersection of 2 lines. Let's say we're given the equation of 2 lines. One line has equation y plus 2x equals 5. The other line has an equation 4y take away 3x equals -13. Okay, neither in the standard line form, but they're both nevertheless equations of a line. Hopefully by now you would look at this, and if you're asked to solve where do these lines intersect, what's the point of intersection, you would say that must be simultaneous equations. I would call this equation 1, this equation 2. Now some people would look at this and automatically go, let's change them both into 6x. I'll multiply equation 1 by 3 and equation 2 by 2. That would give me 6x and negative 6x, and they will cancel nicely. And that's absolutely fine. Slightly quicker though. Instead of doing creating two new equations, I'm just going to say, well, let's multiply the equation 1 by 4. So I'm going to say, let's multiply equation 1 by 4. Why? Because that will give me 4y and 8x equals 20. I'll call this equation 3. And now if I compare equation 3 with equation 2, right, remember the secret to solving simultaneous equations, we must get a letter to vanish. So I'm going to look at these and go, how can I combine equation 3 and equation 2 to get a letter to vanish? Oh, if I subtract them, 4y, take away 4y, that will do it. So I'm going to do equation 3, take away equation 2. Why? Because 8x take away negative 3x. I'm going to keep positive coefficients in my answer, nice positive numbers. So 4y take away 4y, the y's disappear. If the letter doesn't disappear, then there's no point in what we're doing, we've made a mistake and it doesn't help. But the y's do disappear. 8x take away my minus 3x or negative 3x gives me 11x. On the right hand side, 20 take away negative 13, that becomes 20 plus 13 is 33. Oh, so x is 3. Don't stop there. We've worked out the first coordinate, but we've still to work out the second coordinate. So I'm going to go to the simpler of the equations at the beginning. I've got a choice between 1, 2, and 3, but in equation 1, it's probably got the simplest numbers in. So I'm going to substitute in here my solution that x is 3. So rewrite equation 1. I'm going to substitute in equation 1. So y plus 2x equals 5. Plug in my 3. Y plus 2 lots of 3 equals 5. Y plus 6 equals 5. Take away 6 from both sides. Y equals negative 1. I have an x value and a y value. Not quite finished because the question did not say what is x and what is y. It said give the coordinates of the point of intersection. So I'll write that down as coordinates in a point. All right, so I'm saying x is 3, y is negative 1. Just keeps it technically correct. Before you go on to the next question in your test or exam or exercise or whatever, check that the two values work in both equations. So then we'll see if we're correct. Negative 1 plus 2 3's. Negative 1 plus 6 is 5. That worked. My left-hand side comes to 5, which is what it should. And on my second equation, 4 lots of negative 1. That's negative 4. Take away 3 3's. That's 9. Negative 4, take away 9 is negative 13. That's what we had. So I know that my answer must be correct. And example number 2, again on page 15 in our notes. A sketch is so often a good idea. It lets us see that what the question is about if we're not sure how to proceed, and also makes us see at any point if our answer or our working is making sense. Quite often a sketch, as we're working something through and compared to the sketch, it will ring little alarm bells in the back of your head to say, you've done something wrong, go back and check. So, on the question there, it says there's a line through the point A04. So I've got a point here, 04. So this is my point A with gradient 2. So I've drawn a line there. Again, it's not on squared paper. Right? It's not a hyper accurate. It's just a sketch. So I can get the idea of what's going on. And it says there's another line. The second line is going through 1, 0. So again, if it's not to scale, if that's 0, 4, well, but I'm going to say that that's 1, 0, and also goes through the point 2, minus 1. And says the two lines cross at the point B. And the question, as you can see, says, what are the coordinates of point B? So that's what we're going to fill in. Now I know that my first line is gradient, according to the question, 2. What things do we need for the equation of a line? Gradient and a point on the line. We have those two things for the first line here. Gradient is 2. We have a point on the line. In fact, we have the point where it cuts the y-axis. So we know how to write that one down, right? Y equals mx plus c. So straight away, I can say for my first line, y equals 2x plus 4. One equation in place straight away, just from the information that the question told me. What about the second line? Gradient and a point on the line. Well, I can get the gradient. Now at this point, there are 5 ways you should know for getting the gradient. You should probably pause the video for a few seconds and say, can you list off all 5 different ways? First way we know, change in y over change in x. I have 2 points, so I can absolutely do that. So I'm going to say gradient number 2, gradient of my second line, change in y over change in x. Change in y, negative 1, take away y coordinate is 0, so that's minus 1, take away 0, over change in x, 2, take away 1. Oh, so my gradient for my second line is negative 1 over 1, it's minus 1. Now I'll use good old y minus b, mx minus a. Pick a point on this line. I'll pick this one because it's got a 0 for my y coordinate, so it'll be nice quick over here. Y take away 0 is negative 1. X take away 1. Y is minus x plus 1. I'll check and see if that makes sense. There we are, a line coming down the way. This would be the point 0, 1. It's just a sketch, so that's fine. Excuse me. So there's my equation of my second line. I want to combine y equals 2x plus 4 with y equals minus x plus 1. You may well be used to solving this in the way that we solved example 1. So many x plus so many y equals a number, get the x's or y's to cancel. Right? There is a second way to do it. So what I'm going to show you is, I have this equation here, y equals minus x plus 1, but I also know that y equals 2x plus 4 at this point here where the two lines cross, because it's the same y and x for both lines. So y is 2x plus 4. Oh, that means I can replace y here with 2x plus 4. Because that's what the equation of line 1 tells me. Here we go. Oh, so now they've done that. Here's an equation. We've got rid of a letter. That's a fundamental principle for solving simultaneous equations. We've eliminated the y by substituting in. So now I'm just going to solve this equation. I'll add x to both sides, 3x. I'll take away 4 from both sides, minus 3. There we go. X is minus 1. Pick the simpler of the two equations. Y is negative x plus 1. It's probably the simpler. It doesn't really matter which one I use though. Y is minus x plus 1. Y equals minus negative 1 plus 1. That's 1 plus 1, y equals 2. My point of intersection then is negative 1, 2. I'm going to check it works in both formulas. Negative 1, 2. Y is minus 1, that's plus 1 is 2. That works. And in the first equation, y equals 2 lots of -1. That's -2 plus 4 is plus 2. So y is plus 2. That's what I wanted. And finally, it checks on my diagram. For the coordinates of this point here, could this be the point -1, 2? Yes, it makes it's not a sketch to scale, but that makes complete sense. So I've worked out the coordinates of B are -1, 2. And if you get to the end of your higher examination and you've not had to go back and do some kind of simultaneous equation somewhere, right, that would give you pause for thought. It's not always there, but it's usually there. Combining the equations of two lines to find a point of intersection.